In this last set of practice problems, just like in the previous extension, we want to go between a decay factor and a decay rate. So remember, a decay factor, that's the multiplier that goes into an exponential equation, and the decay rate is the percent that describes how that value is changing, often over time. And that's usually what, like I was saying, a lot of times in statistics, what's communicated is a percent, whereas the piece that goes into the equation that you're using to make those predictions, the actual number that's being used to predict it, an exponential change, would be the decay factor, the multiplier. So we want to go back and forth between those. So like I did before, when you're thinking of these, think about a hypothetical 100. It could be $100, it could be 100 milligrams of medication, it could be 100 people with the coronavirus. And then you're thinking about what would you multiply that number by to achieve these percentages of change? 0, 50, 3, 75, 100, 1.5. So that's what I'm going to talk through as you check your work. So first of all, you want to think if something is decreasing by 0%, you have like $100 and it lost value at 0%, it wouldn't change at all. And so just like before with growth, if something doesn't change at all, the factor that you're multiplying it by is 1, which I know seems strange, but if something doesn't decay at all, it doesn't go down at all, has the same value after one period as it did before, 0% change, the number you'd multiply it by to achieve that would be 1. Uh, so that's kind of one of the weird ones. Another one of the stranger ones also is going to be that 100%. So I'm also going to talk about that one to start off with, actually. So think if something goes down by 100%, that means you've lost all of it. If something decreases completely by 100%, nothing's left. So if you had $100 and it went to $0, it's not a very good investment. You would have lost 100% of your value. The number you would multiply that number by to achieve that change would be 0. You multiply it by 0 to make something decay by 100%. Now for the others, like this 15% decay rate, if something goes down by 15%, you're trying to think, what would you multiply that number by to reflect how much is remaining? So when you're multiplying your number, you're multiplying it by something so that you have the correct amount remaining. So if something goes down by 15%, 85% would be remaining. 85% remains, that gives you your decay factor. You would multiply something by 0.85, or 85% in decimal form, to have 85% left, 15% is gone. So just dwelling on this one a little bit longer, imagine if you had $100, it lost value by 15%, your $100 would now be worth $85. The thing you would multiply 100 by, turn it into 85, would be 0.85. Using that same line of thinking, if something goes down by 3%, so 3% is lost, what amount would remain? Well, 97% would remain. And you would multiply something by 0.97 to achieve that. If something goes down by 75%, so your $100 loses value by 75%, you've lost $75, you have $25 remaining. So that would be 0.25 would be the multiplier that would turn a value into, would decrease the value by 75%. 75% is gone, 25% remains. So you multiply by 0.25. And finally on this one, 1.5%, if, again, using $100 as an example, if your $100 goes down by 1.5%, that's $1.50, you now have $98.50 left. To turn 100 into $98.50, you'd multiply it by 0.985. So to kind of formalize the algorithm that I'm using here, what I'm really doing is I am subtracting that percent from 100. So I'm subtract the decay rate, percent, from 100%. So subtract the decay rate from 100%, because remember the decay rate tells you how much it goes down by. You want a number that tells you how much remains. Okay, so something goes down by 75%, 25% remains. And then convert that value to a decimal. So going the other way, we're going to do that in reverse. So we're going to find the decay rate, the percent associated with each decay factor. So we want to say, if you multiply a number by this factor, what percentage does that number change by? And again, I'm going to use my hypothetical 100. So with this first one, 0.6 as a decay factor, that would be a multiplier in an exponential equation. If I took a number, I use 100 because it's easier to talk about percents with that number. If I took 100 and I multiplied it by 0.6, that equals 60. So when I multiplied that number by 0.6, my $100 dropped by $40. $40 out of $100 is 40%. So my decay rate for this one would be 40%. Think of it as if I multiply something by 0.6, I have 0.6 or 60% of that remaining. If I have 60% remaining, 40% has been lost. And a decay rate tells us how much it's changing by or how much it's losing as a percent. So I could do that same thing for 0.05. So if I took 100 and I multiplied it by 0.05, I would have just 5. So if $100 became $5, that means I lost $95. $95 lost out of 100, that's 95%. Likewise with this one, if my $100 is multiplied by 0.085, my $100 becomes $8.50. So it becomes $8.50. That means I have lost $91.5, and my decay factor would be 91.5. And for this last one, if I multiply by 0.85, my $100 would go down by $15, so that would be a 15% decay rate. So with this one, it's kind of the flip side of what we were doing before. Is what we're really doing is you could convert the factor into a decimal. Or sorry, I should say we're converting the factor into a percent. And then subtracting that from %. And so remember that works because when you convert the factor into a percent, that percent is the percent that remains after each time period. usually. So that tells you the amount that's remaining after each time period. But the way we tend to communicate that is how much it changed by, like how much, what percentage it's losing each time. Especially like with money, this is big, is how much as a percentage is going down. You'll see this a lot in the news right now, with all the unemployment numbers and what's happening to the economy, as well as all the numbers describing what's happening to coronavirus infections and deaths and so on. Um, there's the percent remaining, and then there's the percent that is lost. And when we talk about a decay a decay rate, we're reporting the percent that it's changing by, the percent that it's lost.